Although algebra tiles are very useful because they show us all the individual parts of our area, so when I have our 2x plus 2 times x plus 1, we can see along the length and width our 2x plus 2, we can see our x lengths here, our 1's lengths here, our x width here, and our 1's width here. We can see all the individual parts of this. And furthermore, we can see all the area pieces. Our 2x squareds are here, our 4x's are in these two spots here, and then the plus 2 is our area here. So the algebra tile model is our length times width, and we get those area pieces, which are the yellow pieces. This is very useful because we see the individual parts, but it also becomes a bit bulky because we don't necessarily need to always see every single piece. So really what we want to do is make sure that we represent all the different parts of the distribution. We want to show that we have distributed the 2x times the x. We want to distribute the 2x times 1, the 2 times the x, and the x times the 1. And we can show this really in the 4 parts. If we split up the algebra tiles to these parts, the 2x times x gives us the 2x squareds here. The 2x times 1 gives us the 2x's that we see here. The 2 times x gives us the 2x's that we see here. And the 2 times 1 gives us the 2 1's that we see here. So we don't really need to see every individual tile. We can just split this up into the 2 parts horizontally and 2 parts vertically. And when we do that, we can see that 2x times x gives us 2x squared. There it is there. We can see all the individual parts of the distribution. So 2x times 1 gives us the 2x here. The 2 times x, so the length of 2 times the width of x gives us this 2x here. And then the 2 times 1 gives us the length of 2 that we get here. That's a typo. That should be a 2. So this simplified area model is a much easier way to deal with this if we don't need to see each individual part. We can see that the 2 parts horizontally and the 2 parts vertically give us the 4 pieces of the area that we're looking for. And so when we expand this out, we have 2 minus x times 2 minus x. This is really 2 minus x squared, so we end up with a square shape. And when we distribute this out, well, we have our x squared in here. We have 2x's here. This is actually negative 2x because we have negative 2 times x. We have negative 2x's here, and we have positive 4 down here. And we really just need to show that in our simplified area model, because the simplified area model shows us all 4 parts of this distribution. Our first, outside, inside, last. And that gives us our first, outside, inside, last. And we can combine the like terms then. The negative 2x here, the negative 2x here, combines to give us the middle term, negative 4x. The x squared and the plus 4 are individual areas. They're not combined with anything else, so we can show them in separate, their own rectangular area pieces. So that's the important idea of shifting from algebra tiles to our simplified area model, and we retain the key part of in the simplified area model, seeing the 2 pieces of length, 2 pieces of width, and the 4 pieces of area. So that's the key that we want to make sure that we retain when we go to the simplified area model. So here we have this area of 2x plus 6. We can factor this or break this up into length and width. Since we have 2 parts, we really only need 1 part along the vertical, and then we have the 2 parts along the horizontal, and we can factor the greatest common factor along any side here. So they share the common side length. This 2x plus 6 shares a common side length of 2. That gives us the 2 along the vertical, and then we can divide to get the length along the horizontal. Okay, because 2x area divided by 2 gives us that x length. 6 divided by 2 gives us the length of 3, plus 3.